Hi there, I'm Atul and I'm an online tutor based in London.
Hi, I'm Paul and I'm a chemistry tutor based in Burnley, Lancashire. Okay, today we're going to have a look at addition polymerization, which is where we change the monomers, alkenes, into polymers. So with a few examples here we can have a look at. The first one is chloroethene. We've been given the structure of the alkene and we just have to name the polymer, give the structure for the polymer and the repeating unit for the polymer. So the name of it at first is straightforward. We just add the word poly in front of the name of the alkene. So this would just be polychloroethene. So we'll write that in.
Right.
Polychloroethene. And then the structure for it, well, how it's written there is the ideal way of writing for polymerization. Because if we just copy that across, the structure of the polymer will just be the monomer, but instead of a double bond, it will be a single bond because the other bond is being used to form the polymer. And so our structure is this structure repeated thousands of times. So we've gone from the small monomer to a long chain polymer. And the repeating unit there is just what's in our bracket for the polymer, because it's that bracket that's repeating along the chain of the polymer. So we can just, and that with a single bond is our repeating unit for polychloroethene. Okay, and even though our polymers now have single bonds, they're not alkenes, but we name them after the alkene they form from. So it is still called polychloroethene, even though there's no double bonds. So looking at the second one here, well, we've got 3 carbons in a row. So the name for this will be propene. So we go meth, eth, prop for 1, 2, 3 carbons in a row. So we've got propene there. And we don't have to say prop-1ene or prop-2ene because that's the only place that the double bond could go, or whichever carbon we put it on, it would always be on the first carbon. So our name for this, we can just put poly in front. So this would be polypropene.
Poly, I think it means many or something in Greek, doesn't it? Or like that, something like that. Yeah. Yeah. And also, presumably, this is back to the repeating unit. It's got the continuing. Do you just need that, or do you need the bond either side as well?
Yes, we can, to show that that's repeating. So here, the best way of drawing propane, if I draw propane first, so the best way of drawing our polymer is like this, because then the double bond just turns into a single bond. So looking at the propane structure, the first carbon just has hydrogens on it, and the second carbon has a hydrogen and a CH3 group on it.
Right.
So if I just get rid of the double bond now and form a single bond, and then show that those electrons are being used to form the polymer from the other bond, then that repeated lots of times is our polymer structure. And the middle of that is our repeating unit. So I wonder, Atul, having seen those first two examples, would you be able to have a go at these last two examples?
Yeah. So this is actually going the other way around, isn't it? You before had, yeah. So just like the rest of them, all the polymers have a poly prefix. So the monomer would be the thing before the polymer prefix, poly prefix in this case, acrylonitrile. I think that's what it says, doesn't it? So I'm going to write it out actually. So,
good luck.
Yeah. Acryl.
Okay, acrylonitrile, yeah, not much space there, but you managed.
Yeah. And I mean, it's not very clear what this is, but I'm going to guess this is a square bracket.
Yes.
Oh, okay. So actually, that's interesting. I haven't seen this one before, but I suppose you can use the same ideas and work them out. So there's a CH2 group there, so let me make that from scratch. And there's a CH there, so that's that. And then there's a C triple bond with a nitrogen. So the monomer always is centered around the carbon-carbon double bond, because that's where the join happens. And this is, well, it's just the same as that, isn't it? But without the square brackets, basically.
Well, the best way to do this is to look at your monomer.
Oh, yeah. Yeah, that's true. So let's get that down. That double replaced with a single. Pretty much all the same. And the extended bond both ways is to show that this continues both ways.
Yep. Excellent.
And for this one, I would say, again, yeah, it's a very similar in format. Ethanol.
Yeah. An alcohol with an alkene group.
Right. So as opposed to ethanol, it's ethanol because there's a double bond, carbon-carbon. Right. Yeah, I think I'm pretty happy with that. And then for the repeating unit, I'm just gonna make a copy of that. It's gonna be clever about it, but I'll write it out manually. Carbon, carbon, extend. I've extended that out a little too much, but it's fine.
Excellent. And that's it. So you see, as long as we write the alkene in that format with two carbons with four groups coming off, even though there might be more than one carbon coming off the two carbons, then it's quite easy just to change the double bond to a single bond to write the polymer structure and the repeating unit structure.
And presumably you can also show that if you wanted to with a given number of repeat units. So you could say, I'm going to write it out as 3 connected units of propene.
Yes. Yes, sometimes, and that might happen in the question, show 2 or 3 repeating units of this polymer.
And then the more generalized form, I suppose, as a mathematician, n being as many as you want. And how long can n be? Just typically, I mean, for polypropene, for example, is that like thousands or?
Yeah, it's in the thousands.
Right.
That's why polymers are so strong, because of the forces between long chain polymers.
Fantastic. Yeah, it's a good one. Yeah, thanks very much for that. Yeah.
Okay, thanks, Hassel.
All right. Catch you next time.
See you next time.
Bye.
Bye.